All right, in this section 3.5, analyzing arguments with Euler diagrams. First off, Euler is spelled E-U-L-E-R. I have something, and I want it to appear. Okay, I'll put it down here. Euler. It's pronounced Euler. Now, you have to be careful, because if you mispronounce Euler 3 times, he will appear and give you a math test. Don't say Euler. That's terrible. Don't do it. Okay. So in this section and the next section, we talk about the validity of arguments. There's 2 huge things that are going to occur, but we'll talk about that in a second. In this section, we do it with what's called Euler diagrams, which are basically just a bunch of circles, and you're going to see examples of this. In the next section, we do it via truth tables. The words in this section are important. Typically, not typically, but in this class at least, when you have an argument that has the words some, all, none, an Euler diagram is better. If it's a bunch of if, then, or regular statements, a truth table is better. That's really the big distinction between the 2 sections. And you'll see both. Okay. However, there is something humongous we have to discuss, and if I did it correctly, it's going to like fade in. Yay! An argument is valid if the fact that all of the premises are true forces the conclusion to be true. Pause the video if you need to and read that a couple times. That's pretty heavy. In this section and the next, we are definitely going to have to forgive truth for a second, and we're going to have the premise. We're going to have to assume that all the premises are true, even though they may not be true. We're going to just assume that they're all true. If you want to dive deeper into that, take a logic course or get a logic book. This is actually the one I had when I was in college really years ago. Yeah, I still have it. So much highlighting. So much highlighting. A lot of tears. No tears. Anywho, so in this section, next big takeaway, we're assuming the premises are true. All right, you'll see an example of what that means in the videos. Okay, but here is the other huge thing: boop. Validity and truth are not dependent. Just because the argument is valid does not mean the argument is true. Just because the argument, I'll say it that way. Validity means that the conclusion follows from the premises, and the conclusion may not be true. So as I mentioned last time, this is great for battling internet trolls, because you can be like, that's an invalid argument. You can't say that based on those premises. So have fun. For example, go online. Have a conversation with someone. It's fine. It'll be fine. Okay. Let's do an example. We're actually going to do 2 examples in this video, and you'll have more to look at in the other videos. We're going to look at 2 arguments. The very first one on the left is extraordinarily famous. It is mentioned in every single logic class, discrete mathematics class, yada, yada, yada. All men are mortal. Socrates is a man, therefore Socrates is mortal. Same rules as Euler. If you mispronounce Socrates 3 times, he and Euler will come and give you a math test. FYI, you've been warned. Okay, the way that these are done is, even though it doesn't have the words if then in there, we have to sort of think of ifs and thens. So all men are mortal says if it is a man, then it is mortal. Don't get hung up on the word it, even though it is not a great word for talking about someone. It's just an object in this point, nothing meaningful there. Okay, if it is a man, then it is mortal. The way these circles are constructed is, this one's a nice one, unfortunately. The next one's not. The then is the outer circle, and the if is the inner circle. Meaning that if this circle represented all things that are mortal, then inside the circle of all things that are mortal are all the things that are men. Things that are a man, I'll say. So again, the if is the inside, the then is the outside if you have an if-then statement. All right, so this is the beginning of our Euler diagram. So now we go to the next one. Socrates is a man. There are three possible places we could put Socrates. We could put him outside. I wish I knew where my cursor was. We can put him out here. Well, then if we put something out there, those are things that are not mortal, because everything that is mortal is inside the circle. Well, we don't know anything about that just yet. We're just told that he's a man. So it can't be out here. I'm just going to put an X there for now. I'll erase it in a second. We can put him in here, inside the things that are mortal circle. However, that's not the best place, because we have something very specific about Socrates. What do we know about Socrates according to that second line? Again, we are assuming that all the premises are true. We are told Socrates is a man. Well, he should go inside of the things that are the man circle. So I'm going to put an X here to represent Socrates. Okay. So now we ask ourselves, is it fair to conclude that Socrates is also mortal? Well, notice by putting Socrates inside of the man circle from the second premise, and everything in the man circle is also inside of the mortal circle from the first premise, we can conclude that Socrates is also mortal because Socrates is inside of the mortal circle. So because of that, we call this argument valid. Hooray! This argument has a very famous format that it's going to look like, I forgot what that was called, but I'm not, because it's on a different page. Okay, I did it. This is called the argument format of modus ponens. This is in your book. You don't have to memorize these at all. In fact, they're not even provided for you on the test because I don't want you to focus on them. If this were a logic class, then yeah, you would need to know that. I just want you to make the circle. In fact, FYI, this diagram here is your work and your answer. Well, actually, this is your work. The word valid or invalid would be your answer. A modus ponens always has the format if P, then Q. P, therefore Q. That's what we have here. If it is a man, then it is mortal. That's what this said. Socrates is a man. Therefore, Socrates is mortal. Hooray. Now let's look at the next one over here. Bink. Some cats are yellow. Marshmallow is yellow. Therefore, marshmallow is a cat. All right. Some, the thing with the word some is may or may not be. So as far as the outside circle would be things that are yellow. And how we deal with some cats, well, we draw it partially covering the other circle. So this would be things that are cats. The reason we do that is because this region here are cats that are yellow. This region here are cats that are not yellow. Because they have to be cats because they're inside the cat circle, but they may or may not be yellow. That's how sum works. So if you have the word sum, if you have the word all, you have one circle inside the other. If you have the word some, you have one circle partially overlapping the other. If you have the word none, you have two disjoint circles. That's how that plays out. That should cover pretty much all the problems. You'll see. Okay. Marshmallow is yellow. All right. Assuming that premise is true, where do we put marshmallow? Well, here's the fun part. We know Marsh has to go inside the yellow circle, which is the larger one. But he could go here, or he can go here. Therefore, marshmallow is a cat. By our Euler diagram here, can we safely conclude that Marsh is a cat? No, we can't, because it's a possibility that he's yellow and not a cat. That's what this guy says. If this were not here, and we only had this one, where Marsh is a yellow cat, we're good to go. But because we're not sure, we would say that this argument is invalid. Wah, wah. Do not assume that arguments that have the word all are valid, and arguments that have the word some are invalid. That would be an unsafe conclusion. Good times here. Okay, that's pretty much this section, and you do have a couple of videos to watch for it. Let me look. Yeah. Oh, no, you just have the one video. Okay, that's good. So if you would watch video number 42, there are, that's why. There are 5 examples. That's why you only have the one video. So if you would watch video number 42, you'll see 5 examples. One of them includes the word Mr. Snuggles. Mr. Snuggles is a cat. Oh, there you go. I must have cats on the mind, even though I only have dogs. Marsh, you good boy? He's lazier than I am. All right, watch video 42. Have a great day.